Okay, now we're ready for part 3 of the lab, which is entitled Forces and Mass. So in the previous part of the lab, we found out how forces and acceleration were related, and so now we're going to see how forces and mass are related to each other. So it says to click on the motion box at the bottom of the simulation. So if we go back to here, this time we're going to go down to the bottom and we're going to click on this. And so this is a different simulation. Okay, then it says to click on values, masses, and speed boxes. So values, masses, and speed. And you see we get a speedometer here, and it tells you what the mass of this box is. It's 50 kilograms. Okay, now it says to move the applied force slider so that it's 100 newtons. Now, you're going to move it over to about 100 newtons, and you're going to observe what's happening to the box. Well, it's kind of hard to tell what's happening to the box, but look at the speedometer. So do you notice that the speedometer was doing something as long as you were applying a force? And it says to describe that motion. So when you're applying the force, what is the motion of the box? What is it doing? Then it also says, so let's go back here. So describe the motion. Okay, then it says once the box is moving, stop applying the force, and then note what happens to the speed. And then the question is, which of Newton's 3 laws is being illustrated? So you got Newton's first law, Newton's second law, Newton's third law. So which of those 3 is being illustrated when you no longer are applying the force, something is happening to the speed? So you got a 33% chance of getting that right. Okay, now we're going to replace the crate with a refrigerator. So we go back to the simulation here, and we're going to reset it, and then we click on the values and the masses and the speed again, and we're going to get rid of the crate, and we're going to replace it with a refrigerator. So what property of this is different than this? So looking at this number right here ought to give you a clue. So by changing it to a refrigerator, we change something about the object that is being pushed. So replace the crate with the refrigerator. What property have you changed? And then number 11, run the simulation. What is different about the motion this time? So apply the same force to the refrigerator and observe how it's moving this time, and how is it different than how it was moving before. Now, once you've got that, see if you can answer question 12. A force causes an object to accelerate. If a smaller mass is used, then the object's acceleration will be A, less, B, more, or C, the same. Now, if you don't know the answer to this yet, hopefully by the time that we get finished with the lab, you will know the answer, and you can always go back and change question 12. But go ahead and try to answer it right now. So here is one of those technical problems again. How is the acceleration related to the mass? So is the acceleration, is it going to be proportional to 1 over the mass, or is the acceleration going to be proportional to the mass? So you got a 50-50 shot at getting this right. So based on what happened when you increase the mass, what did it do to the acceleration? So remember, if you put something in the bottom part of the formula and then you make it bigger, what comes out gets smaller. If, on the other hand, the m is in the numerator, if this gets bigger, then this gets bigger. So you go back to the simulation if you have to, increase the mass, see what it does to the acceleration, and then pick either this one or this one as your answer. Okay, so that takes care of part 3. So let's take a break, and when we come back, we will do part 4.